You know, whenever I look up at the night sky, particularly when Mars is visible, that bright, distinctive, rust-colored spark drifting against the fixed backdrop of the stars, I feel the same pull that I think we all feel. It is a tremendously romantic vision, isn't it? The idea that that little red dot is a destination. We've been told, and I must admit, Eve participated in this narrative myself over the years, in my documentaries and books, that Mars is humanity's next frontier. We are told that it is our backup planet, our plan B, that one day we will terraform it and build great domed cities there, and that our descendants will look up at Earth as just a bright star in the Martian night sky. It is the stuff of science fiction, the dream that has driven space exploration for decades. It speaks to something very deep in our nature, the explorer's instinct, the desire to push past the horizon, to sail the new ocean. But here's the thing, and I want to be very careful with my language here because this is important, perhaps the most important realization we can have as a species right now. I think it's impossible. And I don't mean impossible in the sense that it's just very difficult, or that it will cost a lot of money, or that we need to invent a slightly better rocket. I mean fundamentally, physically, and biologically impossible for humans to establish a permanent, self-sustaining civilization on Mars. We are talking about constraints that are woven into the very fabric of biology and physics. Constraints that we cannot simply engineer our way out of with enough willpower and funding. I think we need to be honest about this, brutally honest. Because whilst we are dreaming about Mars colonies, whilst we are pouring resources and intellectual effort into plans for Martian settlement, we are neglecting the one planet that actually can support human life. We are neglecting Earth. And that strikes me as not just foolish, but potentially catastrophic for our future. To understand why this dream is a fantasy, we have to start with a fundamental truth that I think we often forget because we live in such a pampered environment. The universe is not designed for life. It is actively hostile to it. We exist in a tiny, fragile bubble of conditions that are absurdly benign by cosmic standards. We walk around in short sleeves. We breathe freely without thinking about it. We drink liquid water that falls from the sky. It all seems so normal, but it's not normal. It is profoundly weird. The default state of the universe is a vacuum, bathed in lethal radiation at temperatures that stop chemistry dead in its tracks. When we talk about Mars, we often use the language of the frontier, comparing it to the European exploration of the Americas or the crossing of the oceans. But those analogies are dangerously misleading. When humans spread across Earth, even into the harshest environments like the Arctic or the high deserts, they were moving into places where the fundamental physics still supported life. You could breathe the air. Liquid water existed. Biology was already there. Mars is not like that. Mars is effectively a vacuum. It is a place where the simple act of existing is a continuous, high-stakes battle against the laws of physics. Let's start with the most immediate problem, something we take utterly for granted: the atmosphere. Right now, you are breathing a mixture of nitrogen and oxygen at a pressure of about 101 kilopascals. That pressure is not just a number, it is a physical force that holds you together. It is what allows your lungs to extract oxygen. It is what keeps the water in your blood from boiling. Every single system in your body, from the cellular level up, has evolved over 4 billion years to expect this specific pressure. Now, let me tell you about Mars. The atmospheric pressure on the surface of Mars is about 600 pascals. That is 0.6% of Earth's atmospheric pressure. It's not just thin air like at the top of Mount Everest. By Earth standards, it is essentially a vacuum. If you were to step out onto the surface of Mars without a pressure suit, you wouldn't just suffocate. Something much more horrific would happen, and it would happen almost instantly. Because the pressure is so low, the boiling point of liquids drops dramatically. This is basic thermodynamics. On Earth, Water boils at 100 degrees Celsius. At Martian surface pressure, water boils at about 10 degrees Celsius. Now, the human body is 37 degrees Celsius. That means that the moment you are exposed to that environment, the water in your soft tissues, your eyes, your mouth, the lining of your lungs would immediately begin to boil. This isn't because it's hot. It's a phenomenon called ebullition. Your own body heat would cause your fluids to vaporize. Your tongue would swell and bubble. The moisture in your lungs would turn to vapor, filling your chest with gas. It would be profoundly unpleasant. You wouldn't explode. As some sensational science fiction movies might suggest, your skin is tough enough to hold you together, but you would be in tremendous pain, and you would lose consciousness within about 15 seconds as the oxygen was ripped from your blood. Death would follow within a minute or two. This isn't like diving where you can hold your breath. You cannot hold your breath on Mars. If you tried, the pressure differential would rupture your lungs instantly. This is an environment where exposure for even a few seconds is fatal, and that has profound implications for how we would have to live there. It means that every single moment of your life on Mars, you are one mechanical failure away from a gruesome death. A tear in your suit, a cracked seal on a window, a failure in the airlock recycling system, any of these things kills you. On Earth, we have margins for error. If your heating fails in Antarctica, you have hours to fix it or put on warm clothes. If you run out of water in the desert, you have days. On Mars, there is no margin. There is only sudden, catastrophic failure. And whilst that might be an acceptable risk for a highly trained astronaut on a temporary mission, is it acceptable for a civilization? Is it acceptable for a family? For a child? To live in a world where a loose bolt or a degraded rubber seal means instant death? I don't think so. I think the psychological burden of that, the constant low-level terror of knowing how fragile your existence is, would be unbearable over the long term. But let's assume we solve that. Let's assume we build the perfect habitats, perfect seals, unbreakable glass. We still have to deal with what lies outside that glass. Because the lack of atmosphere doesn't just mean you can't breathe, it means you aren't protected. Here on Earth, we are shielded by two magnificent invisible barriers. First, the thick atmosphere absorbs high-energy radiation. Second, and crucially, Earth has a powerful magnetic field generated by our churning molten iron core. This magnetosphere extends thousands of kilometers into space and acts as a deflector shield, bouncing away the solar wind and charged particles from the sun. Mars has no magnetic field. It lost it billions of years ago when its core cooled and solidified, and its atmosphere is so wispy that it blocks virtually nothing. The result is that the surface of Mars is bathed in a constant rain of radiation that is lethal to biology over time. We are talking about galactic cosmic rays, high-energy particles from distant supernova explosions moving at nearly the speed of light and solar, energetic particles from our own sun. On the surface of Mars, you would receive a radiation dose of roughly 250 millisieverts per year. To put that in perspective, the average person on Earth receives about 2.4 millisieverts per year from natural background radiation. So, just by standing on Mars, you are absorbing more than 100 times the radiation you would on Earth. This isn't the kind of radiation that makes you glow or gives you superpowers. It's the kind that smashes through your DNA like a microscopic bullet. It breaks the double helix strands of your genetic code. It causes mutations. It dramatically increases your risk of cancer. The European Space Agency sets a career limit for its astronauts, a maximum amount of radiation they are allowed to absorb in their entire lives. That limit is 1,000 millisieverts. If you lived on the surface of Mars, you would hit that lifetime limit in just 4 years. 4 years. And then what? You've exceeded the safe dose for a trained astronaut who has accepted the risks. What does that mean for a colonist who plans to live there for 30 or 40 years? It means their body would be slowly destroyed by the environment. Cancer rates would be sky high. But it's not just cancer. We are seeing evidence now from mouse studies that this kind of cosmic radiation, heavy ions smashing into brain tissue, causes cognitive decline. It damages the neural networks. It increases anxiety. It affects memory. So we might be sending people to a world where the environment itself slowly erodes their ability to think, to solve problems, to remember who they are. And then there is the question of the next generation. If we are talking about colonization and not just exploration, we are implying reproduction. We are talking about having babies on Mars. But what happens to a human fetus when it is bombarded by cosmic radiation? We know from tragic history here on Earth, from Hiroshima, from Nagasaki, from Chernobyl, that radiation causes profound genetic damage. It causes birth defects. It causes developmental abnormalities. We have absolutely no data on what happens to human reproduction in deep space radiation environments. It is entirely possible, I would argue it is probable, that a fetus simply could not develop normally. The delicate orchestration of cell division and genetic transcription that turns a single cell into a human being might be disrupted by the constant flux of high-energy particles. So, how do we solve this? The proponents of colonization will tell you that we can build shielded habitats, we can cover our cities in meters of Martian soil, or regolith, or we can live in lava tubes, great underground caverns left over from Mars' volcanic past. And yes, physics says that if you put enough rock between you and the sky, you can block the radiation. But think about what that means for the quality of life. It means you aren't really living on Mars. You are living in a bunker times, under times Mars. You cannot have windows. You cannot look out at the landscape. You are living in a sealed, artificial cavern, under millions of tons of rock, breathing recycled air, lit by artificial light. You are completely cut off from the surface environment. Is that the grand vision of humanity among the stars? Living like mole rats in tunnels? And you would have to stay there. You couldn't just pop out for a walk. Every time you stepped onto the surface, you would be accumulating your radiation dose, ticking down the clock on your own health. This brings us to a fundamental misunderstanding about what space is. We tend to view space through the lens of terrestrial exploration. We think of it as a place we can go to, conquer, and settle, just as humans settled the continents. But space is not a frontier in that sense. It is more akin to the deep ocean or the interior of a nuclear reactor. You can visit the bottom of the Mariana Trench in a submarine. We have done it. It is a triumph of engineering. But you cannot live times there. You cannot build a civilization there. The physics is fighting you every second of every day, and Mars is the same. It is a dead world. I see people looking at photographs of Mars, those beautiful, desolate landscapes, and projecting their dreams onto them. They see a blank canvas, but biology doesn't care about our dreams. Biology requires specific conditions: pressure, temperature, chemistry, stability. Mars offers none of these. The temperature on Mars averages about -63 degrees Celsius. At the poles, it drops to -125 degrees Celsius. These are temperatures where carbon dioxide freezes out of the air. It is so cold that standard lubricants freeze, metals become brittle, and electronics fail. If your heating system fails on a Martian night, you don't just get cold, you freeze to death in hours. And remember, you are millions of miles from the nearest hardware store. There is no calling a technician. There is no supply chain. This logistical nightmare is the first layer of impossibility. The distance alone makes the concept of a colony absurd. Mars is, at its closest, 55 million kilometers away. A radio signal takes anywhere from 4 to 24 minutes to get there. That means you can never have a conversation with Earth. You can never say, "Houston, We have a problem and get an immediate answer. By the time they hear you, you've been dead for 20 minutes. And physically moving things there, with current propulsion technology, it takes 6 to 9 months. And you can only launch every 26 months when the planets align. This means if a critical water recycling pump breaks and you don't have a spare, you are dead. You cannot wait 2 years for a replacement. The International Space Station, our greatest achievement in space habitation, is only 400 kilometers away. We send supplies constantly. It is not self-sufficient. It is essentially a suburb of Earth, utterly dependent on the mother planet. Mars would have to be 100% self-sufficient from day one, in an environment more hostile than Antarctica, with no possibility of rescue. That level of technological perfection, maintained over decades, without access to the industrial base of Earth, strikes me as a fantasy. Things break. Entropy increases. Systems degrade. On Earth, we fix them. On Mars, when the machine stops, you die. But even if we could solve the vacuum, and the cold, and the radiation, and the logistics, even if we could build the perfect, shielded, nuclear-powered, self-repairing bunker, there is a deeper problem. A problem that resides not in the environment, but in us, in our very cells. We are not just times on times Earth, we are times of times Earth. We evolved here. Every strand of our DNA, every organ, every physiological response is tuned to the specific physical constants of this planet. And the most fundamental of those constants, one that we cannot shield against, cannot engineer away, and cannot ignore, is gravity. We often think of gravity as just a force that holds us down, something we have to overcome to launch rockets. But gravity is the architect of our bodies. And when you take a human being, a creature shaped by 4 billion years of 1 gram gravity, and place them in a 0.38 grams environment like Mars, strange and terrible things begin to happen. Things that I believe make the long-term survival of our species on another world biologically impossible. And that is where the real tragedy of this colonization narrative lies. Not in the difficulty of the engineering, but in the incompatibility of the biology. We can build rockets that go to Mars. We cannot build humans that belong there. We are about to step into the medical reality of what happens when you leave the cradle. And I warn you, it is not a story of adaptation and triumph. It is a story of decay. Because the moment you leave Earth, the clock starts ticking on your own body. The universe begins to reclaim the complexity that evolution fought so hard to build. So, we have arrived at this rather unsettling realization that the universe is fundamentally hostile, that the vacuum and the radiation are trying to kill us every second. But let's say we solve that. Let's say we build the perfect bunker. We still have to deal with a problem that is, in many ways, even more intractable because it is invisible. It is the problem of gravity. Now, gravity is something we take utterly for granted, isn't it? You drop a cup, it falls. You jump, you come back down. It is so woven into the background of our lives that we rarely think about it as a biological force. But gravity is not just a force that holds your feet to the floor. Gravity is the architect of your body. Every single system in your physiology, your bones, your muscles, your heart, your balance, your blood pressure, has been sculpted by 4 billion years of evolution to operate against the constant, unyielding pull of Earth's gravity, 9.8 meters per second squared. We are not generic biological machines. We are Earth specialists. And when you remove that gravity, or when you reduce it significantly, the human body doesn't just float. It begins to dismantle itself. Mars has a surface gravity of about 38% of Earth's. That sounds manageable, doesn't it? You might think, oh, wonderful, it'll be lighter, I can jump higher. And yes, initially, it might feel liberating, but your body is tremendously efficient. It hates to waste energy, maintaining structures it doesn't need. On Earth, Your skeleton is constantly being broken down and rebuilt by cells called osteoclasts and osteoblasts. It is a dynamic system, maintained by the stress of your own weight. But in reduced gravity, your body looks at your dense, heavy skeleton and says, "We don't need this anymore." The osteoclasts, the breakers, start working overtime, and the osteoblasts, the builders, slow down. The result is rapid, catastrophic bone loss. In the microgravity of the International Space Station, astronauts lose bone density at a rate of about 1% to 2% per month in their weight-bearing bones, the hips, the spine, the legs. To put that in perspective, that is roughly 10 times the rate of bone loss seen in elderly patients with osteoporosis, except this is happening to fit, healthy people in their prime. And this happens despite them exercising for 2 hours every single day on specialized resistive machines, 2 hours of sweating and lifting just to slow the decay. Now, we don't know exactly what happens at 38% gravity. We have no data. We have data for Earth gravity, 1 gram, and data for zero gravity, 0 grams. Mars is somewhere in the middle, but I suspect, and this is a fear shared by many space medicine researchers, that 38% is not enough to stop the rot. It might slow it down, but over years, over a lifetime, your skeleton would become brittle. You would become fragile. And it's not just the bones, it's the heart. Your heart is a pump designed to push blood upwards against Earth's gravity to reach your brain. Take away the gravity, and the heart doesn't have to work as hard. So, like any muscle that isn't used, it atrophies. It actually shrinks. Simultaneously, the fluids in your body shift. On Earth, gravity pulls fluids down into your legs. In space, or in low gravity, those fluids migrate upwards into the chest and head. Astronauts get what they call puffy face syndrome. They look congested, but the real problem is what that fluid does inside the skull. It increases intracranial pressure. It pushes against the back of the eyes. We are seeing a condition now called SANS spaceflight, associated neuroocular syndrome. The pressure flattens the back of the eyeball and swells the optic nerve. Shutterstock. Some astronauts return from space with permanent vision changes. They need glasses where they didn't before. Now, imagine living with that fluid shift, not for 6 months, but for 10 years. Imagine going blind simply because you are on the wrong planet. But here is the aspect of gravity that I find truly haunting. It's not about the astronauts we send. It's about the children they might try to have. If we are talking about a civilization, we are talking about families. We are talking about babies. We know that gravity plays a crucial role in embryonic development. Cells need to know where down is to organize themselves. We have done studies with pregnant rats in microgravity, and the results were disturbing: developmental abnormalities, skeletal issues. We have absolutely no evidence that a human fetus can develop normally in 0.38 grams. But let's assume for a moment that a child is born on Mars and survives. That child would grow up under 1/3 gravity. Their bones would likely be thinner, their muscles weaker, their heart smaller than a human born on Earth. They would be adapted to Mars. And that sounds fine, until you realize the implication. That child could never come home. If a Martian-born human tried to visit Earth, the moment they stepped out of the spacecraft, they would be crushed by our gravity. Their bones might snap under their own weight. Their heart might not be strong enough to pump blood to their brain. They would pass out. They would require a robotic exoskeleton just to stand up. So, by settling Mars, we aren't extending humanity. We are speciation. We are creating a race of Martians who are forever exiled from the world of their ancestors. They would be prisoners of their own biology, trapped on a freezing, red rock, looking up at the pale blue dot of Earth, the only place in the universe where their species can walk freely, and knowing they can never, ever go there. That strikes me as a profoundly sad existence, a permanent separation. And what about the environment they are trapped in? I mentioned the lack of atmosphere earlier. but I didn't talk about the ground beneath their feet. We call it soil when we look at pictures, but it isn't soil. Soil is a living thing. Earth soil is teeming with bacteria, fungi, nematodes, organic matter. It is a complex ecosystem that has co-evolved with plants for millions of years. The stuff on Mars is regolith. It is dead rock. It is crushed basalt. But it's worse than that. Because there is no wind or water erosion in the traditional sense to smooth down the particles, Martian dust is incredibly sharp. It's like microscopic shards of glass. It shreds mechanical seals. It gets into lungs. And chemically, it is toxic. We have discovered that the surface of Mars is covered in perchlorates, salts of chlorine and oxygen. Perchlorates are used on Earth in rocket fuel and fireworks. They are toxic to the thyroid gland. They are toxic to humans. They are toxic to plants. So, when you see those movies where the astronaut shovels some red dirt into a bucket and grows potatoes, it's nonsense. If you planted a potato in Martian regolith, the perchlorates would kill it. Or, if the plant somehow survived, it would absorb the toxins, and eating it would kill you. To grow food on Mars, you would have to chemically wash and process tons of soil to remove the poison, or bring all your soil from Earth, which is impossible due to the weight. So you are living in a bunker, your bones are decaying, your vision is blurring, your children can never leave, and the very ground outside your door is poisonous. This is not a fixer-upper planet. This is a planetary toxic waste dump that happens to have a nice view of the Milky Way. And this leads us to the systems we would need to survive there. Because if the biology is fragile, the technology has to be perfect. And I mean perfect. On Earth, if a machine breaks, it's an inconvenience. On Mars, if a machine breaks, it is an existential threat. We love to talk about self-sufficiency. It is the buzzword of colonization. We say, oh, the colony will become self-sustaining. But I don't think we appreciate what that actually means. It means producing everything you need: air, water, food, medicine, spare parts, using only the resources you have on hand, forever, without help from Earth. Consider the complexity of the world we live in. Consider the supply chain required just to make the microphone I am speaking into, or the computer you are listening on. It requires mining rare earth elements, refining them, manufacturing silicon chips in clean rooms that cost billions of dollars, processing plastics, copper, gold. It involves a global network of millions of people with specialized skills. A Mars colony of 100 or even 1,000 people cannot replicate that industrial base. They cannot build a chip foundry. They cannot manufacture a new spacesuit when the old one wears out. They cannot synthesize complex antibiotics when the supply runs dry. So, they are not independent. They are utterly, desperately dependent on the lifeline from Earth. They are like a diver on a very long air hose. And that air hose is 55 million kilometers long. And this brings us to the psychological horror of the distance itself. You see, we are social creatures. We are used to connection. But on Mars, the isolation is absolute. The communication delay, that 4 to 24 minutes of silence between saying hello and hearing a response, destroys the possibility of human connection as we know it. You can never have a conversation with your family back home. You can only send voice notes into the void and wait. And if something goes wrong, if a fire breaks out, if a plague starts, if the main computer crashes, there is no rescue. The fastest ship is 6 months away, and that's only if the planets are aligned. For most of the time, help is 2 years away. Can you imagine the psychological pressure of that? Knowing that you are on your own, that there is no safety net, that if you make a mistake, everyone you know dies? I think we underestimate the fragility of the human mind under that kind of pressure. We have seen what happens in isolated environments on Earth. In the 1,990 seconds, there was an experiment called Biosphere 2. 8 people sealed themselves inside a giant greenhouse in Arizona, a closed ecosystem, fully stocked with food, water, plants, oxygen. It was paradise compared to Mars. They had gravity. They had sunlight. They could see the Earth outside the glass. And it failed. The oxygen levels dropped. The carbon dioxide spiked. The crops failed. The crew split into factions and stopped talking to each other. They came out starving and psychologically frayed. And they were there for 2 years, with the option to open the door if it got too bad. On Mars, you cannot open the door, and you are there forever. I think we are rushing towards this idea of colonization without stopping to ask if human beings are actually capable of it. Not just technologically, but psychologically. We are creatures of the earth. We need nature. We need wind and rain and green and the chaotic, messy vitality of a living world. To lock ourselves in a sterile tin can on a dead world, watching our bodies decay and our machines degrade, strikes me not as a noble destiny, but as a slow, terrifying suicide. And this brings us to the question of why. Why are we so obsessed with this idea? Why do we cling to the belief that we can live there, despite all the physics and biology screaming no? I think it's because we are looking for an escape. We are looking for a backup plan. But as we will see, there is no backup plan, and the belief that there is one might be the most dangerous thing of all. So, we are forced to confront the reality that the human body is fragile, exquisitely tuned to Earth, and liable to fall apart when removed from its cradle. But let's act as the ultimate optimists for a moment. Let's imagine that genetic engineering solves the bone density problem, or that we accept living as frail, pumpkin-headed Martians in wheelchairs. We still face a hurdle that I believe is often hand-waved away in science fiction, but which any engineer will tell you is the stuff of nightmares. It is the myth of self-sufficiency. We hear this phrase constantly in discussions about Mars, a self-sustaining colony. It sounds robust, doesn't it? It sounds like the American pioneers packing a wagon and heading west. But think about what that actually means in a technological society. The pioneers could chop down trees to build cabins. They could hunt for food. They could dig a well for water. The environment provided the raw materials for survival. On Mars, the environment provides nothing but poison and radiation. Everything you need to survive, every breath of air, every drop of water, every calorie of food, every watt of heat must be produced by complex machines, and machines break. Entropy is a law of the universe, just as fundamental as gravity. Systems degrade. Seals crack. Electronics fail. Here on Earth, our civilization rests on the specialized labor of billions of people. When you pick up a pencil, just a simple pencil, you are holding the end product of a supply chain that spans the globe. The graphite was mined in one country, the wood grown in another, the paint produced in a third, the rubber for the eraser in a fourth. It took ships and trucks and factories and chemical plants and thousands of people to put that pencil in your hand. Now, look at the computer systems required to run a Mars habitat. Look at the life support scrubbers. Look at the medical imaging equipment you would need to monitor that bone decay we talked about. These are orders of magnitude more complex than a pencil. To manufacture a modern computer chip, you need a fabrication plant that costs billions of pounds to build. You need ultra-pure silicon. You need rare earth elements. You need photolithography machines that are some of the most precise instruments ever created by humans. A Mars colony of a few hundred or even a few thousand people cannot reproduce that industrial base. They cannot build a chip foundry. They cannot synthesize complex pharmaceuticals when their supply runs out. They cannot manufacture high-tech polymers to patch a suit. So, what happens? They become utterly, terrifyingly dependent on Earth. The self-sustaining colony is a myth. It is actually a remote outpost at the very end of the longest, most fragile supply chain in human history. And when a critical component fails, and it will fail, they can't just 3D print a new one if they don't have the raw feedstock, which also has to come from Earth. This leads to a phenomenon that I think is inevitable for any off-world colony: technological regression. As high-tech equipment breaks and cannot be replaced, the colonists would have to fall back on simpler, cruder technologies. They would be fighting a losing battle against the degradation of their own infrastructure. They wouldn't be building a shiny, futuristic society. They would be scavenging parts to keep the air scrubbers running, living in a state of permanent emergency. And this brings us to the distance, the sheer, mind-numbing vastness of the void between us and them. We talked about this briefly, but we need to really feel the weight of it. Mars is not just far away. It is effectively in a different temporal reality due to the speed of light. At its closest, Mars is 55 million kilometers away. At its furthest, 400 million kilometers. That means a radio signal takes anywhere from 4 to 24 minutes to travel one way. If you say hello, you wait up to 48 minutes for a reply. There is no Zoom call. There is no real-time conversation with loved ones. There is no telemedicine where a surgeon on Earth guides your hands during a crisis. You are disconnected. And physically, it takes 6 to 9 months to get there with current propulsion. And you can't just leave whenever you want. You have to wait for the planets to align, which happens every 26 months. This is the launch window. If you miss it, you wait 2 years. So, if a plague breaks out in the colony, or if the water recycler suffers a catastrophic failure, or if a solar flare damages the radiation shielding, there is no rescue. The cavalry is not coming. The ambulance is 2 years away. Imagine the psychological burden of that. Imagine being a parent on Mars, looking at your sick child, knowing the medicine that could save them is sitting in a warehouse on Earth, and there is absolutely nothing you can do to get it. This isolation brings us to the psychological dimension, which I think is perhaps the most overlooked factor of all. We are social animals. We evolved to live in complex communities, embedded in a rich sensory environment. We need nature. We need variety. We need the ability to walk away from people who annoy us. In a Mars colony, you are trapped in a sealed environment. You cannot go outside without a suit. You breathe recycled air that probably smells of sweat and machinery and chemicals. You see the same faces every single day. You eat the same hydroponic algae paste or whatever managed to grow in the radiation-shielded greenhouse. We have run experiments on this, and the results are not encouraging. I mentioned Biosphere 2 earlier, that sealed greenhouse in Arizona in the 1,990 seconds. It was a paradise compared to Mars. Sunlight, gravity, trees, an ocean, and yet the 8 people inside fell apart. The social cohesion fractured. They split into tribes. They starved. The oxygen levels dropped so low they had to pump it in from the outside. But on Mars, there is no outside. If the oxygen drops, you die. If the social order collapses, you die. We see something similar in Antarctica, a phenomenon called winter over syndrome. Researchers who spend the long, dark winter at the South Pole often experience depression, irritability, cognitive impairment, and sleep disturbances, and they know they can leave in a few months. On Mars, the sentence is life. There is no going back, practically speaking. The cost and difficulty of a return journey are so high that for most colonists, it would be a one-way trip. You are exiled. You are in a prison of your own making, surrounded by a vacuum that wants to kill you, dependent on machines that want to break, living with people you might grow to hate, with no escape, forever. And for what? This brings us to the economics of the situation, which are, quite frankly, absurd. We have to ask, who is paying for this? The International Space Station cost about £120 billion to build. It costs billions every year to maintain, and it supports just 6 or 7 people in low Earth orbit. If you scale that up to a Mars colony, you are talking about trillions of pounds, not just once, but sustained over decades. There is no business case for this. There is nothing on Mars that you can mine and sell for a profit. Gold? Platinum? Even if Mars were made of solid gold, the cost of lifting it off the surface and shipping it back to Earth would be far higher than the value of the metal. Some say, oh, private companies will do it. Billionaires will fund it. But you cannot run a civilization on charity. You cannot sustain a city of thousands on the whim of a few wealthy individuals. Eventually, the money runs out. And when the money stops, the resupply ships stop. And when the ships stop, the colony dies. So, we are looking at a project that is physically lethal, biologically degrading, psychologically unbearable, and economically ruinous. It is a project that offers no return on investment other than the symbolic value of planting a flag. It strikes me that what we are really talking about here is not a rational expansion of the human species. It is a fantasy. It is a form of escapism. We look at the red planet and we see a blank slate. We imagine we can leave behind the messiness of Earth, the politics, the poverty, the environmental destruction, and start over. We imagine a utopia in a dome, but we would bring our human nature with us. We would bring our tribalism, our greed, our short-sightedness, and we would be unleashing those traits in an environment where the margin for error is zero. In a pressure cooker environment like a Mars colony, our worst tendencies would likely be amplified, not cured. It is a sobering thought, isn't it? That we might be fundamentally incapable of living anywhere else, that the universe has given us exactly one home. And if that is true, if the dream of the stars is actually a mirage, then that changes everything about how we should view our presence here. It changes the stakes. Because if Mars is not an option, if there is no plan B, then Earth is not just our cradle. It is our lifeboat. It is the only sanctuary we will ever have in an infinite, cold, dark universe. And right now, we are treating that lifeboat with a recklessness that borders on madness. We need to talk about the opportunity cost. We need to talk about what we are sacrificing to chase this impossible dream. And we need to talk about what it truly means to be the custodians of the only living world we know of. Because ultimately, the fact that we cannot live on Mars might be the most important lesson the universe has ever taught us. It is telling us, in no uncertain terms, to look down, not up, to value what we have before it is gone. This leads us to what is perhaps the most seductive and yet the most dangerous argument of all in favor of colonization. We hear it constantly from billionaires, from futurists, from science fiction writers. It is the argument of the backup planet. The idea is that we need to become a multi-planetary species to ensure the long-term survival of humanity. We are told that keeping all our eggs in one basket, Earth, is too risky. We are told that if a catastrophe were to strike here, an asteroid impact, a nuclear war, a supervolcano, a runaway pandemic, humanity could be wiped out. But if we have a colony on Mars, the species survives. It sounds tremendously compelling on the surface, doesn't it? It sounds like basic risk management. Diversify your portfolio. Don't bet everything on a single horse. But when you actually examine this argument with the cold, hard logic of planetary science, it falls apart completely. Let's think about the worst-case scenarios for Earth. Take the classic example, an asteroid impact. 66 million years ago, a rock about 10 kilometers wide slammed into what is now the Yucatan Peninsula. It was a catastrophe of biblical proportions. It wiped out the non-avian dinosaurs and about 75% of all species on Earth. It threw enough debris into the atmosphere to block out the sun for years, causing global cooling, acid rain, and the collapse of food chains. But here is the crucial point. Even after that impact, even in the midst of that apocalypse, Earth was still habitable. Life survived. Small mammals survived. The atmosphere remained breathable. The oceans didn't boil away. Gravity remained at 1 gram. The magnetic field kept shielding the surface. Now, compare a post-asteroid Earth to Mars on its best day. Mars has no breathable atmosphere. Mars has lethal radiation. Mars has freezing temperatures. Mars has toxic soil. Even if Earth were hit by a civilization-ending asteroid, it would still be infinitely more hospitable than Mars. You could still walk outside and breathe the air, even if it was smoky. You wouldn't explode. You wouldn't need a pressure suit to survive 5 minutes. The same logic applies to nuclear war. Yes, a full-scale nuclear exchange would be horrific. It could kill billions. It could collapse civilization. It could cause a nuclear winter. But it wouldn't strip away the atmosphere. It wouldn't turn the planet into a vacuum. Even a radioactive, scorched Earth offers a better chance of survival for humanity than a frozen, airless, radiation-blasted rock 55 million kilometers away. So, the idea that Mars is a lifeboat is simply wrong. It is not a lifeboat. It is more like a coffin. It is a trap. If we cannot survive on a damaged Earth, a world that is still fundamentally suited to our biology, we certainly cannot survive on Mars. The backup planet narrative is a fantasy that distracts us from the reality that we have nowhere else to go. Economists call it opportunity cost, the value of the best alternative you give up when you make a choice. And the opportunity cost of chasing the Mars dream is staggering. We are talking about spending trillions of pounds to establish a colony. We are talking about dedicating the brilliant minds of our best engineers, physicists, and biologists to solving the problems of keeping a few hundred people alive in a vacuum. Imagine if we took those resources, that money, that political will, that intellectual horsepower, and applied them to the problems we face right here. The cost of a Mars colony is roughly the same order of magnitude as the cost of completely transforming Earth's energy infrastructure to renewable sources. Think about that. We could solve climate change. We could halt the loss of biodiversity. We could lift billions of people out of poverty. We could provide clean water and education to every child on the planet. But instead, we are talking about building luxury bunkers on a dead planet. We are talking about escaping. And every pound spent on Mars is a pound not spent on Earth. Every hour of public discourse spent debating the ethics of terraforming is an hour not spent debating how to save the Amazon rainforest or the coral reefs. It strikes me as profoundly backwards. It is like inheriting a magnificent, priceless mansion that needs a bit of roof repair, and instead of fixing the roof, you decide to spend your entire fortune building a garden shed in a toxic waste dump. It makes no sense, unless you fundamentally do not appreciate the value of the mansion. And I think that is the core of the problem. We have lost our perspective. We have become so accustomed to the miracle of Earth that we treat it as disposable. We treat it as a stepping stone, a cradle that we are destined to outgrow. But Earth is not a stepping stone. It is the only known oasis of life in an infinite cosmic desert. This brings me to a question that I think we rarely ask ourselves in these discussions. What makes life worth living? What is the purpose of human existence? If the goal is simply survival of the species, just keeping the DNA replicating, then perhaps sticking some humans in a bunker on Mars makes a twisted kind of sense. But is that all we are? Is our goal just to exist? To persist? Like bacteria in a petri dish? I don't think so. I think what makes human life meaningful is flourishing. It is the richness of experience. It is the appreciation of beauty. It is connection with each other and with the natural world. Think about the experiences that bring you joy. The simple sensory experiences, feeling the warmth of the sun on your face, smelling the rain on dry asphalt, walking through a forest and hearing the wind in the trees, watching the ocean waves crash against the shore. These are not just pleasant backdrops, they are fundamental to our psychological well-being. We evolved in this sensory landscape. We are tuned to it. On Mars, you would have none of this. You would live in a world of silence, of artificial light, of recycled air. You would never feel a breeze. You would never smell a flower that wasn't grown in a lab. You would never see a river. You would live a life of sensory deprivation. Would that be a life worth living? Or would it be a diminished existence, a shadow of a life? There is a thought experiment in philosophy about a pleasure machine, a simulation that you plug into that gives you perfect experiences. Most people say they wouldn't want it because it isn't real. Well, a Mars colony is the opposite of a pleasure machine. It is a misery machine. It is a simulation of life, but a poor one. It creates a permanent underclass of humans who are biologically human, but exiled from the human experience. And for what? To plant a flag? To say we did it? I think we need to look at the universe with a bit more humility. We often talk about conquering space. We use military language. We talk about colonizing. But the universe is not a territory to be conquered. It is a vast, indifferent ocean, and we are on a tiny, fragile raft. The most profound thing the space program ever gave us wasn't Teflon or Velcro or a bag of moon rocks. It was a photograph. It was the image taken by the Apollo 8 astronauts on Christmas Eve, 1968 Earthrise. For the first time, we saw our planet rising above the battered, gray horizon of the moon. We saw this bright, blue and white marble hanging in the blackness. And then later, Voyager 1 turned its camera back from 6 billion kilometers away and took the pale blue dot image. Earth appeared as a tiny speck of light, less than a pixel, suspended in a sunbeam. Carl Sagan wrote beautifully about that image. He said, "That's here. That's home. That's us." He pointed out that everyone you love, everyone you know, everyone who has ever lived out their lives on that mote of dust. Space exploration didn't show us that we belong in the stars. It showed us that we belong here. It showed us how lonely the universe is. It showed us that there is no one else coming to save us. It showed us that Earth is precious, fragile, and irreplaceable. When I look at Mars, I don't see a future home. I see a cautionary tale. Mars is what happens when a planet dies. It is a world that lost its atmosphere, lost its water, lost its ability to support life. It is a fossil. And Venus is a cautionary tale of a runaway greenhouse effect. We are sandwiched between two dead worlds, living on a miracle. And yet, we seem determined to wreck the miracle in the hope that we can go live on the fossil. It is madness. So, where does that leave us? If Mars is impossible, if the stars are out of reach, if we are effectively trapped on Earth, is that a depressing conclusion? Does it mean humanity has no future? Absolutely not. In fact, I find it strangely liberating, because once you accept that there is no escape, once you let go of the fantasy of the backup planet, you are forced to focus on what actually matters. You are forced to take responsibility. The question is not, how do we leave Earth? The question is, how do we deserve Earth? How do we prove ourselves worthy of this extraordinary gift? How do we build a civilization that can last not just for a few centuries of industrial exploitation, but for millions of years? That is a challenge far greater and far more noble than terraforming Mars. It requires us to grow up. It requires us to move past the adolescent fantasy of running away from home when things get messy. It requires us to clean up our room. We have the technology to do it. We can power our civilization with the sun and the wind. We can feed everyone sustainably. We can protect the rainforests and the oceans. We can eliminate poverty. We can create a world where human civilization functions like an ecosystem, recycling its waste, living in balance with the biosphere. Imagine a future where we have done that. Imagine an Earth 500 years from now. The cities are green and quiet. The air is clean. The climate is stabilized. Biodiversity is recovering, and humans are flourishing, billions of us, living rich, meaningful lives, studying the universe, creating art, loving our families, grounded in the only home we will ever know. That is a future worth fighting for. That is a destiny. And yes, we will still explore. We will send our robots to the ice moons of Jupiter to look for life in their dark oceans. We will build massive telescopes to peer at the atmospheres of planets orbiting distant stars. We might even send daring crews of astronauts to visit Mars, to walk on its surface, to do the science, and then, crucially, to come home. Exploration is beautiful. It expands the mind. But colonization? That is a mistake. We are not cosmic mistakes in the sense that we shouldn't exist, but we are perhaps accidental tourists in a universe that wasn't made for us. The fact that we are here at all, that we are conscious, that we can understand the laws of physics, that we can appreciate the beauty of a sunset that is a miracle, and the fact that we have a world that allows us to do those things is a double miracle. We must not squander it. So, the next time you hear someone talking about the frontier of Mars or the imperative to colonize, look out the window. Look at the trees. Look at the sky. Feel the gravity holding you gently to the surface. Take a breath of this rich, oxygenated atmosphere and realize that you are already in the best place in the universe. You are already home. We don't need to go anywhere else to find our destiny. Our destiny is to be the caretakers of this pale blue dot, to protect it, to cherish it, and to ensure that the story of humanity is not a tragedy of wasted potential, but a long, beautiful love letter to the only world that ever cared for us. Because in the end, Earth is enough. It is everything.